Magnitude of a factor. Magnitude, also known as the norm of a factor, is a measure of its length. To find the magnitude of a factor, you combine the squares of all its components, the numbers representing its position in space, and then take the square root of the sum. For example, if you have a two-dimensional factor with components 3 and -4, you square each of these numbers, getting 9 and 16, and then together to get 25, and take the square root of that 25 to get 5. So the length of magnitude of this factor is 5. Properties of factor magnitudes. Factor magnitudes have several important properties. First, positivity. The magnitude of any factor is always 0 or positive. It is only 0 if the factor itself is a 0 factor. All the components are 0. Homogeneity. If you multiply a factor by a scalar, a single number, its magnitude gets multiplied by the absolute value of that scalar. For instance, if you double the component of a factor, its magnitude also doubles. Triangle inequality. When you add two factors together, the magnitude of the resulting factor is less than or equal to the sum of the magnitudes of the original factors. This is similar to the rule in a triangle that the length of one side is always less than the sum of the other two sides. Dot product of factors. The dot product is a way of multiplying two factors together to get a single number. This number tells us something about the angle between the factors. If the dot product is 0, the factors are perpendicular to each other. To calculate the dot product, you multiply the corresponding components of the two factors together and then add up all those products. For example, if you have two factors with components 1, 2, and 3, 4, you multiply the first component 1 and 3 to get 3, multiply the second component 2 and 4 to get 8, and then add them up together to get the dot product of 11. Properties of the dot product. First, commutative law. The order in which you dot two factors doesn't matter. Dotting factor phi with dot factor w gives you the same result as dotting factor w with factor phi. Distributive law. If you have a sum of factors and you're dotting it with another factor, you can distribute the dot product over the sum. This means you can dot each factor in the sum individually with the other factor and then add the results. Homogeneity. If you multiply one of the factors by a scalar before taking the dot product, it's the same as taking the dot product first and then multiplying the result by that scalar. Positivity. A factor dotted with itself gives a result that is always 0 or positive. It's only 0 if the factor is a 0 factor. In summary, factors are mathematical objects that have both magnitude and direction. The magnitude tells us how long the factor is, and the dot product is a way to understand angles and projection of factors on each other. This concept forms the foundation of much of linear algebra, which has application in physics, engineering, computer science, and many other fields.